On March 8th, 2024, at exactly 2:47 a.m., every radio telescope in the southern hemisphere picked up the same thing, a signal. Clean, structured, repeating every 11.3 seconds. And here's what nobody is telling you. The math doesn't work. The physics doesn't work. And 3 days ago, it changed. I'm going to show you why the world's top scientists are having closed-door meetings right now, and why what I'm about to reveal in the last 60 seconds of this video might completely change how you see our place in the universe. Real quick, drop a comment right now. Where are you watching this from? Your phone? Your laptop? I need to know you're real, because what we're about to discuss, most people still think is science fiction. Comment your location. Let's see how far this reaches. Before we get to the truth, you need to understand 3 things, and I'm going to explain them in a way that will make everything click. But first, listen, if what I'm about to show you matters to you at all, you need to subscribe right now. Here's why. This story is developing in real time. 2 days ago, new data dropped that changes everything. And when the next update hits, you need to be here. We're breaking this first. Hit subscribe, turn on notifications, because missing the follow-up to this, you'll regret it. Okay, let me take you back to where this really started. Not March 8th, that's just when the world found out. No, this began 6 months earlier. September 2023, the Murchison Wide Field Array in Western Australia, late-night observation run. Graduate student named Dr. Yuki Tanaka was running a standard survey, mapping radio frequencies from deep space. Boring work. You're basically collecting static, looking for patterns in the noise. And then she saw it. A spike, small, consistent, coming from a region of space called the Zone of Avoidance. Now that name, it sounds dramatic, but it just means the part of the sky blocked by our own galaxy. The Milky Way is so thick with stars and dust, we can't see through it clearly. It's like trying to see across a crowded room through a wall. You know there's stuff on the other side, but you can't see it. Yuki flagged the signal, logged it, moved on. Because here's the thing about radio astronomy. Space is noisy. Stars pulse, pulsars spin, black holes scream. You get weird signals all the time. Most of them are natural, so she filed it away. But 3 weeks later, it happened again. Same frequency, same duration, same source location. And this time, she didn't ignore it. She ran the numbers, cross-referenced the timing, and that's when she noticed something that made her stop. The signal was repeating, but not randomly. Every 11.3 seconds, exactly. Not 11.2, not 11.4, 11.3 on the dot, down to the millisecond. Now, natural phenomena can repeat. Pulsars do it. They're spinning neutron stars, and they flash like cosmic lighthouses. But they drift. The timing changes slightly over time because they're slowing down, because physics. This signal, no drift, perfect repetition, for weeks. She brought it to her supervisor, Dr. Raj Patel. He's a 30-year veteran of radio astronomy, the guy who helped discover 3 new pulsars. He looked at the data, and his first reaction was simple. Equipment malfunction, must be interference. Cell tower, satellite, something local. So they did what scientists always do. They looked for the boring explanation first. They shut down the array, ran diagnostics, checked every component, tested every frequency. Then they turned it back on. The signal was still there. So they called in help. They contacted the Parkes Observatory. Different telescope, different location, 300 kilometers away. Can you confirm this target? Can you see what we're seeing? 48 hours later, Parkes responded, "We have confirmation. Same signal, same frequency, same timing." That's when things escalated, because if 2 independent telescopes separated by hundreds of miles are seeing the same thing, it's not interference, it's real, it's out there. Dr. Patel drafted a report, submitted it to the International Astronomical Union. Quiet at first, standard channels, no press, no announcements, just, "Hey, we found something weird. Can anyone else confirm?" And then March 8th happened. The European Space Agency's radio network picked it up. SETI, the search for extraterrestrial intelligence, picked it up. Arecibo's successor array in China picked it up. All at once. Same signal, same timing, coming from the same impossible location. The difference was, now everyone could measure it better. More telescopes, more data. And when they ran the full analysis, that's when the physics problem showed up. The signal wasn't just repeating, it was layered. Multiple frequencies, stacked on top of each other, like a chord in music. 3 distinct tones broadcasting simultaneously. And here's the thing that doesn't make sense. Natural sources don't do that. Pulsars emit one frequency at a time. Even complex phenomena like magnetars, they scatter across a spectrum. They don't broadcast clean, separate tones in perfect harmony. But it gets stranger, because when scientists tried to trace the origin point, they hit a wall. The signal was coming from deep in the zone of avoidance, but the distance, the math broke. Based on signal strength, it should be close, maybe 200 light-years away. But based on the Doppler shift, the red shift in the frequency, it's moving fast, receding from us at 1,200 kilometers per second. That puts it way out, tens of thousands of light-years away. So which is it? Close and weak, or far and impossibly powerful? The numbers don't agree. And that's when the closed-door meetings started.
Now, before I tell you what happened 3 days ago, you need to understand what scientists have been quietly debating. Because this isn't just about a weird signal. It's about what the signal implies. Theory 1. It's a pulsar we don't understand. Maybe there's a type of neutron star that behaves differently. Maybe the zone of avoidance is hiding something we've never seen before. It's possible. We've only mapped a fraction of the galaxy. New discoveries happen. But the perfect timing, the layered frequencies, that's harder to explain naturally. Theory 2, it's a technosignature. That's the polite scientific term for it might not be natural. When SETI looks for alien signals, they look for patterns, structure, repetition, things that don't happen by accident. And this signal, it checks every box. The 11.3 second interval, the harmonic frequencies, the precision, it looks designed. But here's the problem. If it's a technosignature, where is it coming from? The zone of avoidance is dense. Thousands of stars, millions of possible sources. Pinpointing one location is nearly impossible with radio waves alone. You'd need optical confirmation. You'd need to see the source. And the Milky Way is blocking the view. Unless, this is theory 3, and this is the one that's making people nervous. What if the signal isn't coming from behind the galaxy? What if it's coming from inside it? What if the source is in the Milky Way but moving? A ship, a probe, something that's not stationary. That would explain the distance problem, why the math doesn't work. Because it's not in one place, it's traveling. And if it's traveling toward us, the Doppler shift would look like it's receding, but only if it entered our galaxy from the far side and is now crossing through. Dr. Helena Cross from Cambridge ran the simulation. If you assume the signal is mobile and you track its apparent position over 6 months, the trajectory is consistent. Something is moving through the zone of avoidance, heading in our general direction. Not directly at Earth, but into the inner galaxy, toward the galactic center. She published her findings in a preprint paper. It got 40,000 views in 3 days, then it was quietly taken down. The official reason? Further peer review needed. The unofficial reason? Someone got nervous. Because if something is moving through our galaxy, broadcasting a structured signal, that's not a natural phenomenon anymore. That's a vehicle. That's intent. That's intelligence. And that brings us to 3 days ago. March 18th, 2025. The signal changed. Not the frequency, not the timing, the structure. A 4th tone appeared. Faint, but there, broadcasting underneath the original 3. And it wasn't random. It was synced, perfectly aligned with the 11.3 second pulse, like someone turned on another instrument in the middle of a song. Dr. Tanaka was the first to catch it.
She compared the new data to the old recordings. The difference was undeniable. For 6 months, 3 tones. Now, 4. Something changed, something activated, or something got closer. And here's the detail that no one is talking about publicly. The 4th tone, it's lower, deeper frequency, which in radio astronomy means one thing: stronger signal, closer source. Whatever is broadcasting, it's either amplifying its output or it's moving into range. The scientific community is split. Half say it's natural, we just don't understand it yet. The other half is asking a different question. If it's not natural, why is it broadcasting? What is it saying? And why now?
Now, here's what I haven't told you yet, the part that changes everything. 2 weeks ago, a team at MIT's Haystack Observatory did something different. Instead of just listening to the signal, they analyzed the gaps, the silence between the pulses. Because in communication theory, silence carries information too. They ran the gaps through a pattern recognition algorithm, looking for structure, variance, anything that wasn't random. And they found it. The gaps aren't consistent. They're almost consistent, but every 47th pulse, the gap is 0.003 seconds longer. Every 103rd pulse, it's 0.007 seconds shorter. Tiny variations, invisible unless you're looking for them. But here's the thing. Those variations, they're not random. They're binary. Long gap, short gap, on, off, 1, 0. It's a code, buried in the timing of the pulses, a secondary layer of information hidden beneath the obvious signal. The MIT team decoded it. It's a sequence, 1,459 bits repeating in a loop. They don't know what it means yet, but the structure is undeniable. It's data, intentional data, embedded in a signal that's been broadcasting for 6 months. And here's the part that no one knows how to process. When they mapped the bit sequence to a 2-dimensional grid, it formed a pattern, not random noise, not static, a shape, geometric, symmetrical. It looks like a diagram, a schematic, like instructions. The paper is being written right now. It's not public yet, but I've seen the draft, and the conclusion is careful, measured, but clear. We are observing a structured signal of unknown origin, exhibiting characteristics inconsistent with known natural phenomena. The presence of encoded information suggests intentional transmission. Translation: this is not a pulsar. This is not a star. This is a message, and someone or something sent it. Now, here's where we are. The signal is still broadcasting, the 4th tone is still there, and the scientific community is trying to decide what to do next. Do you respond? Do you broadcast back? Do you stay quiet and keep listening? Because if you respond and something answers, that's it. That's first contact, and no one knows if we're ready for that. So, let me ask you the question no one wants to answer. If this is real, if something is out there moving through our galaxy, broadcasting a message, what do we do? Do we reach out? Or do we hide? Drop a comment. Tell me what you think. Are we alone, or are we being contacted? And if it's the latter, what happens next? Here's what you need to do right now. 1. Subscribe to this channel. This story is not over. The next update could come any day, and you need to be here when it drops. 2. Share this video. Most people have no idea this is happening. This could be the most important discovery in human history, and it's flying under the radar. 3. Follow the research. Links are in the description. Read the papers. Look at the data. Decide for yourself. Because March 8th, 2024 might be the day everything changed, and we're still trying to figure out what it means. Thanks for watching. I'll see you in the next one. And remember, we're listening. The question is, who's talking back?